Okay, good morning, everyone, or good afternoon. Uh, Today in this session, I would like to answer some of the questions that some of your friends asked me through personal chat. Yeah? I would like to encourage that everyone, if any of you would like to ask, to share your question in the group. That way, when I answer your question, then the answer can also be known by other students, by your friends, so that then we can share the benefit of knowing. Yeah? Otherwise, then then only you will know the answer or the correct answer of that. Secondly, also since my time is limited, yeah, of course I have promised to try to answer each of your question one by one. But if each of you, every one of you, ask similar questions, then and I would have to answer to each of and everyone all the time. Then of course that will be there will be much of time wasted. So if you could please drop your question in the WhatsApp group that we have formed, then I can answer your question one by one there, inshallah, hopefully. Yeah, then everyone else can know the answer and do not need to repeat the same question every time again, every time again. Okay. So here, one of the question asked by your friend is this one. Yeah. So this one is the question in one of the slide that I have given last week. So when we have this 4 milliampere, then having the current split between this 36 kilo ohm branch, and the other one is this is actually this is there are a slide previous to that, and this slide this resistor is um, what do you call it? Uh, Wait a moment. Yeah, yeah. This resistor is uh, is 9 kilo ohm. Yeah, from the parallel result of the 36 kilo ohm and 12 kilo ohm. Now the question is, what if? Sorry, yeah. Okay, screen sharing stuff. Let me share again. Okay, one. Okay, so let's resume recording, and again, let me share my screen, the previous one. Sorry for being cut due to technical problem. Okay, so the question was like this. We have this circuit, and the question being asked by the problem is this V out. And what is V out? So in order that we can know and we can calculate V out, we need to calculate I out. Yeah, this IO, the current that flows through this branch of the resistors from this node. Yeah. So from the previous slide, actually, this slide from a series of slides, maybe there are two resistors that are in series in this branch. One is 9 kilo ohm in series with another 9 kilo ohm. Okay, then uh, it means between this branch there is a voltage division between the first 9 kilo ohm and the second 9 kilo ohm. Of course, they are equally divided because the value of the resistors are the same. Then this 4 milliampere is being branched or being split, yeah, between the 36 kilo ohm and these two 18 kilo ohm. So from here we know that in order to calculate I/O, we can use current division formula. I/O equals to 36K divided by 36K plus 18K multiplied to 4 milliampere. Yeah, here, so let me annotate here. Okay. Okay, so yeah, the above part. Remember that when we want to calculate the current flowing through here, yeah, and we have another current flowing through this path, okay, from the same node, then the current flowing here, this is IO, will be equals to the division here, 36K here, divided by the sum of the two resistors branches. Yeah, 36K plus 18K multiplied by the 4 milliampere. So here we obtain how much? This is 36K divided by 36K plus 18K is 54K. Yeah, so this cancel each other, multiply by 4 milliampere. So we can further divided by 6. Yeah, this is equal to 6 divided by 6 is equal to 9. Even further divide divided by 3, this equals to 2. This is divided by 3 equal to 3. So then we obtain 8 by 3 milliampere. Okay. Then so from this 8.8 over 3 milliampere, we obtain the I have to erase this one and make it clear. Okay, so we obtain this the voltage output by 9 kilo ohm multiplied by that current IO equals to 9 kilo ohm multiplied by 8 over 3 milliampere. So it means then, oops, now share again. Okay, so where is the annotate? Yes. So here 9. Okay, this is 1 and this is 3. Then the kilo also cancel each other, so equals to 24 volt. Okay. Then by keeping the fraction, we preserve full numerical accuracy. Yeah. So okay. So there's no problem. Yeah. Here I think it's not that difficult. So the question is that what diffusion. So what kind of formula we should use here. So first is when the current splits between this node and this node, it means that we have to use current diffusion formula. Okay, because current split here, one towards the 36 kilo ohm, the other one towards the double 9K kilo ohm series. After we obtain IO, then we can immediately use Ohm's law. Yeah, V equals to IR. Yeah. Otherwise, we could of course also use directly voltage divider. How to use voltage divider formula? But it is similar. Basically, we need to know the voltage here, yeah, the voltage here across this. To know the voltage here, so alternatively, we can first calculate the whole resistance, yeah, the whole equivalent resistance from the first branch, yeah, RS we obtain 9K plus 9K ohm, so equal to 18 kilo ohm. Then the equivalent resistor of all, yeah, 36K and in parallel with 18 kilo ohm will be equals to 36K multiplied to 18 kilo ohm divided by 36K plus 18 kilo ohm. Okay, this equals to, this is from the parallel formula. Yeah? The kilo will, no, the kilo is still there. Yeah, the kilo is still here. This is 36K. So this 36 multiplied by 18, yeah, this kilo divided by 36 plus 18 is 54. Okay, 54. So then we can divide 18, this is equals to 1, so this equals to 3. Okay, 36 divided by 3 equals to 12 kilo ohm. So from here, then we can calculate the voltage in VA here, voltage VA. VA equals to 4 milliampere multiplied by the kilo ohm. So this equals to the milli cancel with kilo, so 48 volt. Then we can use voltage divider formula, yeah, to calculate V output. So V output will be equal to 9 kilo ohm divided by 9 kilo ohm plus 9 kilo ohm, okay, multiplied by 48 volt. This is basically half, right? This is 1, this is all 2, so equals to 24 volt. So using this alternative method, we will obtain the same answer, which is that 24 volt. Yeah. Okay. save first this one, then clear all drawing, then we go to the next question. So the next question by another friend of yours asks how to calculate this. There is a what do you call it? Circuit like this. This is what we call as transconductor amplifier. It contains two parts, the left part and the second part, the left side and the right side. And on the left side, there is a voltage divider, yeah, between R1 and R2. So then we can use Kirchhoff voltage law on the left loop to calculate R2 here, to calculate the full VG. Or basically we can immediately use voltage divider formula. Then the current source on the right side is a voltage dependent current source whose value depends on the value of VG. And then it is expressed as GM. GM is the conductor, what do you call it, the multiplication factor multiplied by VG, yeah, the voltage at the R2. Okay, so one node pair on the right, this one. Then the question is, what is V output? So here we can calculate using Kirchhoff current law, KCL, to calculate the current here, the current GM VGT, and then that current using Ohm's law we can multiply. We can multiply with RL to obtain V output. Okay, so on the left side, the Kirchhoff voltage law on the left side, yeah, VI T equals to I1 multiplied by R1 plus R2. Then the VGT will be equals to this I1, yeah, multiplied by R2. So in other words, VGT will be equals to, you substitute this I1 plus R1 plus R2 into this, and it becomes VGT equals to R2 divided by R1 plus R2 multiplied by VIT. So basically, this is a voltage divider formula as we have known already. For the right side, we use KCL. So the upper node, yeah, the upper part here, even though they are drawn as a single line here, yeah, as a single line, but they are connected, right? Remember the first chapter on the definition of a node. As long as that line or the node here, you see this maybe as one single node and the other one as a second node. But however, since they are connected, we can consider them as one single big node. Okay, so having said that, then using KCL node, the current out, yeah, since we assume here that all the current is coming out, so we assume here first current is here, yeah, according to this direction of the current source. The second current also flowing from this node coming out to the RL. So putting that into the Kirchhoff current law, we know that the sum of all currents should be 0. And so then positive GM VGT plus VOT divided by RL. So this is from Ohm's law, and we don't have any current in to this node. So then the right side will be equals to 0. So from here, then we can calculate VOT. The question is VOT. What is VOT in terms of VIT? Yeah. So here, find G equals to the amplification gain equals to VOT divided by VIT. So here, VGT has been calculated from the left side using Kirchhoff voltage law. Here, VGT. So then basically we just need to substitute the value of this VGT into this Kirchhoff current law on the right side. Okay, so as a result, we obtain VOT here equals to minus. Yeah, so this left side is put to the right side of the equation. That is why it becomes negative. Yeah, and it contains still the GM factor and the VGT multiplied by RL. The RL on the lower side on the denominator comes to the right side and becomes numerator. That's why it is multiplied to this minus GM VGT. So then we substitute the value of VG from the Kirchhoff voltage law of the left side, yeah, and we obtain here minus GM multiplied by RL from here, and then multiplied by R2, multiplied by VIT, divided by R1 plus R2. Since the question is the gain VOT divided by VIT, so we just need to to move this VIT from the right side to the left side, it becomes the denominator on the left side. So VOT divided by VIT equals to minus GM RL R2 divided by R1 per R2. So this contain the GM. GM here is the the multiplication factor, yeah, on the dependent current source. Okay, you have to put that multiplied by the resistors on the right side, yeah, the load resistor, as well as the two resistors on the left side. So one question from your friend is that why do we not calculate immediately the two as a calculation because they are connected here? Yeah, in transconductance amplifier they are connected, but usually we just need to calculate them separately, because here that relationship between the left side and the right side has been expressed in this value, yeah, of the current source equals to the VG, the current here equals to GM multiplied by VGT. So no need that we calculate again with using Kirchhoff current law, for example, on the lower node here. No need. So then that will just make things more complicated. Okay. Yeah, I will just save this. Notate and then save. Okay, and then clear all the drawing. Okay, yeah, so I hope that is clear. Now here, another friend of yours asked this question about, this is a single loop circuit that we can usually solve using Kirchhoff voltage law. So the question is, if VAD, if the voltage between A and D is 3 volt, yeah, so A to D here is 3 volt, so it means A is 3 volt higher than D. And then the question is find Vs, okay, find Vs. So this is an inverse divider problem, okay? Yeah, so where does this come from? So if we make a notation, okay? So the voltage here, VAD, basically equal to the Vs, okay, multiplied by this 20 kilo ohm divided by the sum of all the three. Yeah, this is 25 plus 15 plus 20 kilo ohm. Okay, these cancel each other. So this equals to VAD equals to Vs multiplied by 20 divided by how much it is? 40 plus 20 is 60. Okay, 60. Okay, so basically 1/3. So VAD equals to Vs divided by 3. So from here, the Vs equals to 3 times VAD. So equals to 3 times 3 volt equals to 9 volt. Yeah. So basically only this one immediately the solver of this, yeah, the use inverse of this voltage divider. So this one, 3 multiplied to the current the resistor here 20 kilo ohm, sorry, divided by this resistor, then multiplied by the sum of all the resistors. Okay. Now the question asks, yeah, your friends, yeah, ask clear all the drawing. So she used this calculation, right calculation. First, she calculate first I equal to 3 divided by 20 kilo ohm to obtain 0.15 milliampere. The VAD is 3 volt. So here we use VAD equals to Vs plus 25 kilo ohm plus 25 kilo ohm multiplied to current I plus 15 kilo ohm multiplied to current I. Then 3 equals to Vs plus 25K multiplied by 0.15 kilo ohm, yeah, multiplied by 15K multiplied 0.15 kilo ohm times the current. So then she obtained Vs equals to minus 3.7 plus minus 2.25 equals to minus 3 volt. Now how come the value is not the same? So what is forgotten by your friend here is that the passive sign convention. Let's try using her method here. So first we calculate the current flowing through the to the 20 kilo ohm resistors. Yeah? So using the passive sign convention, Yeah, so this is the 20K, and then you have the PS. Okay, you have the 25K here, and then you have the 15K on the other part. Okay, this is C, this is B, this is A, and this is B. So if we look at, we want to find VAD is known to be 3 volt, right? So this is means that plus A is 3 volt higher than D. So if we use Ohm's law, that the current, yeah, equals to VAD divided by 20 kilo ohm, which is equal to 3 volt, yeah, divided by 20 kilo ohm. So this will be equal to 0.15 milliampere. Okay. However, remember that this is the Ohm's law follows or abide the passive sign convention. It means, according to this, the current should flow from or enters to the positive sign of this resistor and then coming out from negative sign. So according to this, the current here should be in this direction. This current of equals to 0.15 milliampere. Okay. So having said this, let's use then Kirchhoff current voltage law to calculate. Yeah? If we use Kirchhoff voltage law, let's say which direction? Yeah, let's see this direction. Yeah, clockwise direction. Using clockwise direction, okay. Or no, just according to the same, so the same as the current's direction. So using counterclockwise direction, okay. And starting from the AD. So VAD is 3 volt, okay, 3 volt we know because it follows the passive sign convention. Then here, yeah, according to here, the current is flowing like this, yeah. So depending on your definition, so let's say your definition is this is plus and this is negative, then you can still follow plus plus I multiplied by 15 kilo ohm. And from here also this is plus and this is negative, okay. And then it follows I multiplied by 25 kilo ohm. However, here it is from negative, the charge, the current flows from negative part to the positive. So you have to put here negative Vs, yeah, not positive Vs, but negative Vs because it goes against the passive sign convention. So it means you have to put negative value to Vs. Yeah. So here then equals to 0. Yeah, so from here we can move the Vs to the right side of the equation. So Vs equals to 3 volt, then plus the current is 0.15 milliampere multiplied by 15K, then plus 0.15 milliampere multiplied to 25 kilo ohm. So this equal to 3 volt is plus 2.25, yeah, 2.25 volt, and plus here 3.75, yeah, 3.75 plus yes, 3.75. So here then we obtain the Vs equal to 9 volt, which is the same result as if when we calculate using the voltage divider formula. Okay, so please be careful when using passive sign convention. Okay, when using passive sign convention, so let us repeat again what is passive sign convention. So I did the drawing here, and we go to the next slide. So what is passive sign convention? So whenever you have a component, let's say a general component, it could be, um, let's say, it could be resistor, it could also be a voltage source, whatever. So you assign a positive like this. Okay, you assign positive like this. Then when the current is like this, so this is what positive. Let's say it is between A and B. A and B. So it means this is VAB, and this is the current. Okay, so this is what the passive sign convention states. So when the current flows into the positive terminal of the of the component, yeah, and the current itself is positive. Yeah. So if the value of the current is positive, voltage here is positive. Okay, so it means it's what is shown by the polarity here is also true. It means then the power at AB will be equals to VAB multiplied by I from A to B, right? Equals to positive. Yeah, positive multiplied by positive equals to positive. So this is passive sign convention. So whenever the arrow is not like this, yeah, whenever the arrow is not like this, but instead, for example, let me erase this one, okay, and uh, oops, undo, oof, sorry, yeah, the current here is on the other side, okay, on the other side here, like this, right? It means current is coming out of the positive. When the number itself is the number of the current, the value of current is positive, value of I is positive. So it means then when you put into the PAB, you have to put PAB, for example, multiplied by IAB here, positive multiplied by negative. The current here is negative. So it means then this component is not absorbing power, the component is dissipating, supplying power. Okay, so for example here is like battery, right? The battery flows, the battery in a battery that supplies power, the current flows into the terminal part of the battery and then coming out from the positive part of the battery. So the battery supplies energy to the charge, the positive charge. Okay, however, when the value of I is negative in this picture, yeah, the current is flowing out of the positive terminal, then you know that the PAB will be equals to PAB multiplied by IAB equals to the polarity is still positive, yeah, because the VAB value is positive. Then the current is negative, but it is negative, yeah, coming out of the positive terminal, but the value is negative. So actually, in reality, it goes into the terminal, right? So it is actually negative times negative inside the current itself. That the power is positive. So it means that the component is dissipating power. Okay, absorbing power and dissipate that power. So like resistors, for example. So be careful with this, yeah. So with how you assign the current. So in electrical circuit analysis, it depends on the arrow direction, or in the case of voltage, on the how you assign positive and negative here, but as well as in this the value of the I and the value of the VAB itself. So when the current, when the flow or the arrow flows to the like this here to the right, however, if the value of I actually is negative, yeah, for example, if the I is negative, then you can redraw to make it simpler for you to understand. You may redraw the circuit to be like this. So actually, the current here is I. Yeah, the polarity is negative. Sorry, like the usual VAB, A and B. However, so now the current value here becomes positive because you have changed the arrow direction to the left. Previously it was to the right, but the value of I is negative. Now you don't like negative value, so you change the value of the current to be positive, but then it means you have to change the direction of the arrow. You cannot change both. Be careful. Yeah, so similar thing with VAB. Yeah, VAB, if for example like this plus minus, you assign to the A is higher than B, but the value is VAB is negative. It means actually then you could, if you don't like this negative value of VAB, you can change that into positive value. However, then you have to reverse the polarity. So B is higher than A. So B is positive, A is negative. Okay. So I hope this explanation can be understood. Yeah. So it's sometimes not that easy at the beginning. Yeah. We got mixed up and we got confused when we have to solve the problem. Okay. The other friend of yours asked this question. So we have this 10-volt voltage source flowing a current I into a load resistance R. This is one of the design and implementation example. When the nominal resistor value, nominal means like the average of the resistor value, is 2.7 kilo. What is the resistor tolerance of? And the resistor tolerance is 10%. And the question asks you, what will be the ranges for the current and power? So remember that when the resistor when it has ranges, yeah, it means 10% like this. It means the value, the actual value of the resistor R will be equal to R0. R0 here, the nominal resistor value, plus minus 10%. So what does it mean? Actually, the range is from 100% minus 10%. How much is 90%, right? Or 0.9 multiplied by R0 until 1.1, 100% plus 10%. Yeah, 110%, or 1.1 multiplied by R0. So this is the value. So having said that, let's continue. So it means now the nominal current, which is when it is the resistor value is at its average, is the voltage divided by the nominal resistance value, yeah, 2.7 kilo ohm, yeah, kilo. So this equals to 3.704 milliampere. The milli here comes because this is kilo. There is a kilo here, yeah. Or maybe for clarity, I will just annotate it. There is a kilo here. This is volt and this is kilo ohm. So then that's why the unit is milliampere. So the nominal power when the resistor is at 2.7 kilo ohm will be equal to 10 square V square divided by that nominal R0, yeah, or 10 square divided by 2.7. This equals to 37.04 milliwatt. Yeah. Okay, so then coming to the other question, what will be the ranges of the current? So since we know already that the resistor range value is from 0.9 R0 to 1.1 R0, it means then the minimum current will be when the minimum current will be when the resistor is the highest, right? The resistor is the high because the resistor is put on the denominator on the lower part. V I equals to V, the voltage divided by R. So the highest value of the resistor is 1.1 multiplied by R0. That is why here we put 1.1 multiplied by the nominal value of the resistor 2.7 kilo ohm. And that is why then the minimum current will be 10 volt divided by 1.1 multiplied to 2.7 kilo ohm. So the value is 3.367 milliampere. The maximum current is happening when the resistor is at its minimum value, which is 0.9 multiplied by 2.7 kilo ohm. So then the maximum current will be 10 divided by this value equals to 4.115 milliampere. Your friend asked then from 3.367 milliampere towards 4.115 milliampere. So the ranges is about 0.7, yeah, 0.7 milliampere. Wouldn't it, so if you compare from the nominal value, 0.7, so 0.7, let's say divided by 3.7 is about almost 20%, 20%. So why is it so big? Yes, it is correct. Remember that plus minus 10%, it means from 0.9% until 110% is 20% range, right? That is why the range of the current is also 20% of the nominal current value. Okay, 20% times 0.7 milliampere is more or less 0.7 milliampere, the range from the minimum current towards the maximum current. Okay, So similarly, actually, with the maximum power, yeah, with uh, the maximum power and minimum power, yeah, the range will be from the minus 0 point, from the 0.9 or 90% of the 90% of the power here, 37.04 milliwatt, which is 33.67 milliwatt into 110% of the nominal value, which is 41.15 milliwatt. So here to here, the range is more or less how much? Seven. Yeah, about 7.4. Yeah, about 7.4 or 7.5. Yeah, 7.5 milliwatt. 7.5 milliwatt, and this is quite large, yeah. So this is 7.5 milliwatt. Let's say divided by the nominal power, 37.04 milliwatt. Yeah, more or less also about 20%. If you multiply by 5, yes, more or less also about 20%. Why? Yeah, because the range is, the tolerance is 10%. So plus 10% tolerance means plus minus 10% of the nominal value. So if the nominal power is 37.04 milliwatt, it means the actual power due to the resistor tolerance of 10% is 90% of this 37.04 milliwatt until 110% of this 0.7 of 37.04 milliwatt. That's why if you design a circuit and you want that this range is not that big, you want it to be very precise or very accurate, then you have to use resistor with small tolerance, let's say 5% or even 1%. Okay, so this is in the design implementation. Yeah, you have to take into account this resistor tolerances. Okay, let's go then. Yeah, wait a moment. What is saying here? Okay, it's clear on drawing. The ranges for current and power are determined by the tolerance, but the percentage of change may be different from the percentage of tolerance. The ranges may not even be symmetric. Okay, okay. So another question from your friend is, yeah, we have here multiplied sources, current sources, and the question asks about this IL, and then there's that flows into the RL equals to 12 kilo ohm here. Okay, so first we solve this by combining the three current source, and then this is 1 milliampere upward, negative 4 milliampere downward, plus 2 milliampere upward. So 1 plus 2 is 3, 3 minus 4 is negative 1 milliampere upward. So if we want to draw the current source, the equivalent current source downward, then we change it into positive 1 milliampere. Remember the discussion on the passive sign convention. So we have here, then we combine the resistor. Okay, so first, since the IL flows to this RL, we don't want this RL to be combined with the other three resistor. We let it alone because we want to calculate the current flows through it. What we can do is we combine the other three resistor into a single equivalent parallel resistors. Yeah, yeah, 1 over Rp equals 1 over 18K plus 1 over 9K plus 1 over 12K. So the Rp equals to 4 kilo ohm. So from here, then we combine this 1 milliampere current source downward multiplied by then 4 kilo ohm and then this 12 kilo ohms downward. Now the question of your friend is, why is it that the value, the minus, there is a minus sign here. Yeah? The sign is minus here. Why the sign is minus here? Why is it not positive? Okay, so the answer to that is because of the if we use Kirchhoff current law, let's say, yeah, we use Kirchhoff current law. Okay, and based on the Kirchhoff current law, so we go to the next slide. Okay. Oops. Okay, we annotate. Okay. Yeah, based on this, let's say we calculate using Kirchhoff current law at the bottom node. Using Kirchhoff current law at the bottom node. So current in equals to current out, right? So let's say the current in, let's say we have to make assumption. What is the current flowing to this for kilo ohm? Okay, or let's say since everything is going down, we usually the assumption is like that. When the current is flowing here, then it should be split, right? It should be split here. And let's say this is I1 and this is I2. Yeah. This is become current out. So it means 1 milliampere here equals to I1 plus I2. Okay? I2 is pointing upward from the I2. So then the current flows through I2. You have to calculate from the voltage first. Yeah, this is using voltage. First, you calculate the parallel resistors. Yeah, the parallel resistors of these two becomes 1 over Rp equals to 1 over 4 kilo ohm plus 1 over 12 kilo ohm. Okay, so this equals to how much? 12 kilo ohm plus 4 kilo ohm divided by 4 times 12. Okay, so this equals to 16 kilo ohm divided by 48 kilo ohm. So equals to 1 over third. So the Rp equals to 3 kilo ohm. Here's the equivalent parallel resistor. So then the voltage, remember passive sign convention, the voltage here then equals to the current multiplied by Rp parallel, so equals to 1 milliampere times 3 kilo ohm equals to 3 volt. Okay, and this is the, since 3 volt here is flowing here, so the sign is like this, is 3 volt. Okay, so this bottom point is higher 3 volt than the upper point. So the current I2 can be calculated. I2 equals to the voltage, yeah, the voltage divided by the resistor there, the R2. So 3 volt divided by 12 kilo ohm, okay, equals to 0.25 milliampere. However, I2 here is pointing upward, while IL is pointing downward. When we change the arrow, so it means then you have to assign we have to multiply by what, negative minus negative 1. So IL here will be equals to negative I2. So equals to minus 0.25 milliampere. If we want to be straightforward, what we can do is immediately we use current divider formula. This is another method. Yeah, using current divider formula. So I2 will be equals to 4K divided by 4K plus 12K multiplied by 1 milliampere. Okay, so this will be equal to 1/3, right? I2, sorry, 4 plus divided by 16, 25%. So this equals to 0.25 milliampere. But again, so this is more straightforward. Using current divider more is a faster method. However, again, since IL is pointing downward, so IL equal to negative I2 equals to negative 0.25. So that is why that the current is negative. Okay, I think, oh yeah, the annotation is still there. Clear on drawing. That's all for today. For answering all the questions from your friends. I hope you understand this explanation, and I wish you success in the upcoming quiz. Bye bye for now.